All right, here we go. So these first two, I'm going to go through all of the different things that you need to know. So you can make sure that you are understanding what to do for each of these. Does that make sense? Okay, so I'm going to tell you how I know what I know, how I'm going to represent that, how I know how to represent that, et cetera, et cetera. So in the first part on a position versus time graph, the slope is my velocity. So here I have my positive slope, so I'm going to have a positive velocity. And it's not super steep, so I know that it's going slow. Positive velocity means I'm going forwards. And it's not very steep, so that means that I'm going slowly. In the second part, this part is flat. It's horizontal. My slope is 0. When my slope is 0, that means that I am not moving. So here I'm not moving. And then during the third part, this is steep, which means fast. And it's a negative slope, so that means I'm going backwards. So going backwards fast. All right. The next part of this is then my velocity versus time graph. So on a velocity versus time graph, how far up you are is what determines how fast you're going. So this makes sense because if I take my velocity versus time graph and I put a 0 here, it goes 1, 2, 3, 4, 5. So if I was saying I was going fast, that would be up higher. Well, the same thing would apply if I'm going fast, going backwards, except that now if I want to have a bigger negative number, faster is going to be down here compared to there. Does that make sense? Good? Okay. So for this first part where my velocity is positive and not super fast, I need to have a velocity that's positive and not super steep. So that means not very high up. I could even have it a little bit lower. Okay. Then during the next part, my velocity is 0. I know that because it is flat. It is horizontal. So this slope is 0, which means that my velocity here is going to be 0. And the last part is going backwards. And it's going backwards fast. It's a very negative slope, so I'm going to have a very negative velocity. So one thing to pay attention to here is make sure that this line is closer than that one. So when it's farther away, it's faster. And this one is closer, so it's slower. All right. Then I'm going to do my motion maps. So on my motion map, I'm going to start with going forwards. But one thing I need to consider is where did I start? Well, I need to look at my position versus time graph to figure out where I started. Specifically, I'm going to look right here. So I started fairly high up. So that means that I need to make sure that I don't start at 0. So if this is 0 meters, I need to start somewhere over here. And then I'm going to go forward slowly. So I'm going to start by going forward slow. You need at least 2 arrows. And then I'm going to label these times T0, T1, T2. Then I stopped. That's when I stack my dots. That'll be time 3 and time 4. And then I went backwards. And when I went backwards, I went faster, which means that my arrows are longer. And then I can label these T5 and T6. Now, if you had 3 arrows instead of 2, awesome. That's totally great. If you had 4 arrows, that's also fine. If you have 1, that's not enough. Does that make sense? Okay. Now, if you notice, I'm not the most perfect drawer. Okay, I can look at these arrows and I can say, well, I'm not really sure if this arrow is bigger or not. So what I'm going to do is I'm going to label it V1. And this one's the same, so it's also V1. Over here where it stopped, I'm going to say V2 equals 0. So I'm not just labeling that it's V2, but I'm telling you that that velocity is 0. And then when I go backwards, these are both V3. And then I'm done. All right, I'm going to give you guys a second to finish copying that down. I know there's some of you that are still writing.
Yes.
Alrighty, cool. Next, we're going to do number 2. All right, number 2 is a little bit harder. And the reason why I say that number 2 is a little bit harder is because here you're given your velocity and then you have to figure everything else out. So I'm going to start with going from my velocity versus time graph to my written description, and then I'm going to do my position versus time graph. I feel like that's generally an easier way to go than to just go from your velocity to your position versus time graph. So the first thing I want to mention is this. Your friend calls you up on the phone. Hey, I'm driving 65 miles an hour. Where am I? Do you have any idea where your friend is? You have no idea. All right, so here's my point. My point is this. If your friend tells you how fast they're going, you have no idea if your friend only tells you how fast they're going, you have no idea where they are. So that means that I have no idea where I started, because all you're given on a velocity versus time graph is how fast you're going. So I'm going to start by going backwards fast. And I know that because it's below the horizontal axis and it's far away. So the bigger this is, that means it's fast. And it's backwards because it's down here. Then, during this next part, now it's going up. Well, it's up higher, which means I'm going forwards because it's above the horizontal axis, but it's not very high up, so that means that it's slow. So depending on how high up it is, that tells you how fast, and it's above, so that means it's slow. So I'm going to go slow forwards. And for the last part here, now I'm on the horizontal axis, so that means my velocity is 0. So that means I'm not moving. But I have no idea where I was. So I'm going to look at this and go, well, first thing I do is go backwards fast. So I want to make sure I have space to go backwards fast. So I'm going to start up here, or I could start here. It doesn't matter. Regardless of what I pick, I need to have a steep negative slope. Then during the second part, I have a positive velocity, but it's not very big. I'm going forward slowly. So I'm going to go forward slowly. I'm going to have a small positive slope. And last, I'm going to stop. But it doesn't matter where I'm at. I just have to connect it to where I was. Because if I was going forwards and then all of a sudden I stopped, I'm not going to teleport. Wherever I am, that's where I am. Noses. Thank you. All right, so now I'm going to do my motion map. So I need to go backwards fast first. So I'm going to start over here so I have lots of space. I'm going to go backwards fast. I'm going to go backwards fast. I'm going to label these the same so you know they're the same length. I'm going to label my times. Then I stopped. So I started going forwards. I didn't stop. I started going forwards right away. Now, when you go forward, when you are going backwards fast and then you immediately start going forwards, this needs to be the same number. Whatever time you picked when you switch directions, make sure that that is the same number. And then I stopped. So then I'm going to stack my dots because I'm at the same position at the same time. This is going to be T5, T6. And then I need to label my velocities. So here's V2, V2. And then here my V3 equals 0. All right. So the most common mistake here is that students forget that these need to be the same time number because you were going backwards and you immediately started going forwards again. All right, so what you're going to do now, if you have not finished copying number 2, you can copy it down. And each group is going to whiteboard all of number 3. So every table is going to get a big whiteboard and you're going to whiteboard number 3. Ready, go.